Proxima b is an Earth-sized exoplanet that sits only about 4.24 light-years away from us, orbiting a red dwarf star called Proxima Centauri, which is the closest star to our solar system. Even though it is so near compared to other stars and planets, this intriguing world has become one of the deepest cosmic mysteries ever encountered. Many scientists and researchers across the globe remain fascinated by the unusual and extreme conditions that exist on this remote planet. One of the most astonishing and curious features of Proxima b is its tidal locking. This tidal locking means that one side of Proxima b is always facing the star, soaking in constant, never-ending sunlight that scorches the surface. In contrast, the other side is forever trapped in darkness, frozen under bitterly cold temperatures. Such a contrast creates a world with two extreme environments separated only by a narrow twilight zone where the light from the star barely meets the darkness. This thin region may hold the only zone with milder conditions compared to the blazing day side and the frozen night side. Recent observations made by the James Webb Space Telescope, JWST, have uncovered discoveries that seem even more baffling and difficult to explain. Structured infrared emissions coming from the dark side of Proxima b have been observed to pulse in a pattern that shows mathematical precision. These heat signals do not appear as random warm spots. Instead, they are organized into precise patterns that look very much like the grid layout of modern cities on Earth. These unusual hotspots are releasing radiation in the terahertz frequency range, which is almost never seen in natural environments, but is often used in advanced communication technologies. This discovery has sparked a wave of intense debates and theories in the scientific community. People are asking whether these signals are simply natural wonders or possible evidence of intelligent alien life living beneath Proxima b's icy surface. Researchers have been able to map 12 distinct zones on the dark side of this planet. Each of these zones appears to pulse in synchrony every 27.3 hours. Interestingly, this cycle perfectly matches Proxima b's orbital period, which means it takes the same amount of time to complete an orbit around its star. Such perfect timing leads some experts to think about the possibility of deliberate engineering. Others propose that these repeating patterns could be the result of exotic crystal formations with powerful pyroelectric effects that naturally generate energy. It is believed that Proxima b might contain a molten iron core that is heated by the powerful gravitational forces pulling from Proxima Centauri. This internal heat could rise through the crust and create geothermal networks hidden under thick ice layers. If these geothermal vents are real, they could supply enough warmth to maintain subsurface lakes. These lakes might support simple organisms similar to extremophiles, which are hardy microbes that thrive in Earth's volcanic ocean floors. Backing up this theory, the JWST has detected the presence of ammonia and hydrogen sulfide gases near the areas of emissions. On Earth, these chemicals are often released by microbial life that survive in oxygen-free habitats deep underground or in the ocean. Dr. Sarah Weller of the European Space Agency has explained that if these compounds are tied to biological activity, we could be seeing evidence of a hidden biosphere under the ice. But there is still another detail that makes this even stranger. The amount of energy output from these emission zones is enormous, equivalent to the power of 10,000 nuclear power plants running at once. Many scientists agree that simple geological processes seem insufficient to explain such staggering amounts of energy. This has shifted some of the focus to theories suggesting the existence of artificial energy infrastructure, possibly advanced fusion reactors that produce clean power to support an underground civilization. Despite Proxima b's thin atmosphere, which is only about 0.1% as dense as Earth's atmosphere, the JWST has found titanium dioxide nanoparticles embedded in the ice surface. On our own planet, titanium dioxide is widely known for its ability to reflect solar radiation, but if engineered and arranged in a particular way, it could also trap heat below the ice layers, perhaps keeping underground habitats at stable temperatures. These unique nanoparticles may play a role in forming microclimates within sub-ice pockets, creating just enough warmth to sustain life. Dr. Ling Zhou, who is a planetary engineer, believes these findings could be clear signs of an intelligent civilization working to maintain a livable environment in the darkness. He has stated that we might be observing a civilization's efforts to terraform their own dark world using technologies we cannot yet fully understand. The Twilight Zone, The thin area where the eternal daylight meets the endless night has offered more fascinating clues. Ju's observations have shown signs of glacial movement, hinting that there could be liquid water beneath the ice layers, possibly warmed by radioactive decay of elements like uranium-238. This natural heat could make pockets of water stay liquid, just like in Antarctica's bloodfalls, where iron-rich water flows out from under glaciers. If any life forms are living here, they probably do not depend on sunlight to survive. Instead, they may use chemosynthesis, a process of creating energy from chemical reactions, or possibly magnetoreception using magnetic fields to navigate in complete darkness. Some researchers have suggested that bioluminescent organisms may glow in the darkness using their light to communicate or hunt. Their sensory abilities could be far beyond what humans have ever seen. One of the biggest challenges faced by any potential life on Proxima b is the frequent solar flares blasted out by Proxima Centauri. These flares release intense X-rays and ultraviolet radiation, making the surface nearly impossible to live on without protection. However, underground lava tubes, deep bunkers, or thick ice layers might act as shields, protecting life forms from deadly radiation. Some theories suggest that any civilization on Proxima b could have developed fusion reactors fueled by deuterium extracted from passing comets. Another fascinating clue comes from coherent light patterns seen by JWST, which resemble vast fiber optic networks stretching across the surface. These glowing lines could be part of data transmission systems or even quantum communication arrays designed to send information across the planet or possibly beyond it. If these patterns are proven to be technological, they would be evidence of a level of technology far beyond anything humanity has achieved. Once these miniature probes finally reach Proxima b, they will begin capturing high-resolution images, recording magnetic field readings, and analyzing the chemical composition of the atmosphere and surface materials. These data packets will then be sent back to Earth on laser beams, carrying the first close-up glimpses of the mysterious world that has captured the imagination of scientists and ordinary people alike. Researchers believe these images may help confirm or refute whether the strange emissions and structured patterns are natural processes or clear proof of technological activity. In the meantime, powerful ground-based telescopes like the European Extremely Large Telescope, ELT, currently under construction in Chile, are preparing to monitor Proxima b for any changes or signals. The ELT, with its 39-meter main mirror, will be the most powerful optical telescope ever built, capable of resolving details on exoplanets in unprecedented clarity. Scientists plan to use it to look for reflected light variations, which might indicate artificial megastructures or moving fleets on the planet's surface. Another mission on the horizon is NASA's Habitable Worlds Observatory, which will feature a new generation of coronagraphs designed to block out the glare of Proxima Centauri and reveal faint details around the star. It is hard to overstate the significance of what finding evidence of an intelligent civilization on Proxima b would mean. It would completely transform our understanding of life's rarity in the universe, proving that Earth is not unique and that other species may be thriving under radically different conditions. Even if no intelligent life is confirmed, the existence of a hidden ecosystem of microbes in the twilight or underground regions would still be an astonishing discovery. It would suggest that life can arise almost anywhere, even in extreme environments battered by radiation and locked in perpetual night. Meanwhile, the debates continue. Some scientists caution that the terahertz emissions and strange patterns could be instrumental artifacts or statistical coincidences. They stress the importance of repeating observations and verifying the data through independent instruments before jumping to conclusions. Others argue that the signals are too consistent and precise to be random noise, and that there may be a non-natural explanation waiting to be uncovered. In the popular imagination, Proxima b has already become a symbol of cosmic mystery and the possibility that we are not alone. Science fiction writers have begun crafting stories set on its frozen dark side, describing hidden cities under thick domes, vast underground oceans filled with glowing creatures, and explorers encountering alien intelligences who mastered fusion power millennia ago. Beyond storytelling, Proxima b offers real hope for interstellar exploration. Its relative proximity makes it the ideal first target for technologies like light sail propulsion or nuclear pulse engines that might someday carry robotic missions or even humans to another star system. Engineers are already studying how to design cryogenic hibernation systems or generational starships capable of surviving the decades or centuries needed to bridge the vast gulf of space between Earth and Proxima b. Imagine what it would mean if future explorers touched down on this dimly lit world, drilled through its ice layers, and uncovered an alien infrastructure still humming with power. Imagine the impact of discovering a network of tunnels, fusion reactors, or even artifacts engraved with symbols we cannot yet decipher. Such a moment would not only revolutionize science, but also redefine what it means to be human, showing us that intelligence can emerge independently across the cosmos. This possibility fuels countless research proposals, international collaborations, and new generations of telescopes and probes, all focused on Proxima b as a gateway to understanding the universe itself. Even if the strange signals turn out to be natural, the lessons learned in detecting and interpreting exoplanet data will improve our abilities to study countless other worlds orbiting the trillions of stars in our galaxy. In the meantime, we continue to watch Proxima b's dark side flicker with its mysterious influence.